Hello, Hopewell. Today we're on page 18. We're doing day 5 notes, equations of lines in slope-intercept form, and also something called function notation. We're going to start with our warm-up. In each of these exercises, I want you to just pause the video and see how far you can get, and then unpause the video and watch as I do this with you right now. So we're going to graph the equation. This is an equation in point-slope form. As always, we want to identify one point that's on this line and the slope that's stored in this formula. Starting with the x-coordinate, which is -6, and the y-coordinate, which is +4. This line has a slope of 1/2. So what we're going to do is plot our point first, 6 to the left from the origin, and then 4 boxes up, and plot your first point with a slope of 1/2, which means we're going to rise 1 and run 2 to the right, and repeat this until I go off the graph, and go backwards until we go to the other direction and off the graph that way. If you don't have a ruler, you can use your student ID, connect all these points up, and this is how you graph that equation. Continuing on to part 2, it says rewrite the same equation so that it's solved for y. First, I want to distribute the 1/2 to everything inside of the parentheses. Nothing happens on the left-hand side. In the middle, we have 1/2 x. Half of 6 makes 3. If I'm solving for y, I want to get this y by itself. I'm going to add a 4 to both sides. So we get y equals 1/2 x plus 7. If you did pause the video and you looked at number 3 and wasn't sure how to answer this, let's do this together then. How does the constant number at the end of your equation in number 2 compare with a feature of the graph in exercise 1? The constant at the end of the equation represents the blank of the graph. Alright, so the constant at the end of the equation is a 7. What's 7 about this graph? I got more than 7 points. It might be this point right here. This point is the point 0,7, and that's called the y-intercept of the graph. I abbreviated it y-int, but it is the y-intercept of the graph. And today we're going to explore the formula for slope-intercept. If point-slope was a formula that tells you one point and the slope, then I think slope-intercept formula is going to be an equation where it will tell you the slope and the y-intercept. This is the next formula you're going to need to remember. It's the slope-intercept equation for a line, and I know you are familiar with y equals mx plus b coming into this class. M is still going to represent the slope of the line. Slope again measures the steepness of the line. But now we have this letter b we have not yet seen before. That letter b represents the graph's y-intercept. The y-intercept is the location where the graph hits the y-axis. Any point on the y-axis is going to always have an x-coordinate of 0 first. So whatever this number says, that's going to be where the graph is going to cross through the y-axis. And if we see here there was a 7, that means this graph has a y-intercept of 0,7. Okay. On the bottom part of this page, it's just blank space. I think what I need to know is, in this section, if you remember, there are 4 types of slopes we saw. A positive slope is a graph that goes up from left to right. A negative slope will go down from left to right. So we sketch those. What is a zero slope equation going to look like? Hoy and Vux. Okay, so slope is 0. That's Hoy. So this has a steepness of 0. If I just draw any horizontal line somewhere here, then it will have a slope of 0, and then undefined slope, that's the U in Vux. That means I need to draw any sort of vertical line. And some things to know. We were able to draw or write an equation in point-slope form for these because they had infinitely many points that passed through it and a slope. We can sort of draw a point-slope formula for this one, but you could not do a point-slope formula for this equation because it has no slope. The slope is undefined. This one, for point-slope form, like if for example I pick any point that's on here, this looks like the point 4, 5. I look at another point on this graph, let's do this one, 2, 4, 6, -8, 5. What I'm supposed to notice is that their y-coordinates are the same, 5 and 5. So I could write a point-slope formula with either of these points. I'll just do this point first. Y minus 5 equals a slope of 0 times the quantity x minus 4. But when I put this into Delta Math for homework, it kind of said, hey, let's rethink this. There's something wrong about it. And that's why I had to teach you what's a different way to write this. If you multiply 0 times anything, you get 0. And if you add 5 to both sides, you get the equation y equals 5. So I think when we have a special slope, a slope of 0 or undefined, we have to write our equation just a little bit differently. So this would be the equation y equals 5. Let's see, this line has an x-coordinate of -4. Any point on this, well, let me count that again. 1, 2, 3, 4. Any x-coordinate is always going to be -4 on this line. So we're going to give this equation the equation x equals -4. If all of your y's are the same, you have a horizontal line. If all of your x's are the same, you have a vertical line. But I'm going to redefine what Hoy and Bucks also means. The y at the end means the y coordinates are the same, but it also means we can write an equation that's y equals a number, just like y equals 5. Since all of these x coordinates are the same, I can't use point slope, so I have to use something else. And unfortunately, I can't even write a slope-intercept equation because it doesn't have a slope. That's why this one is kind of very special. When you have an undefined slope, we can't write a slope-intercept equation. We can't write a point-slope formula. We have to write some different type of formula. If all of the x's are the same, then you can write an equation that's like x equals a number equation. And the reason is because this last graph is something that's not a function. It's not a function. A function is anything where exactly one input gives us exactly one output. If I start with an x-coordinate and I say, hey, what's the y-coordinate for that x-coordinate? So for like any of these examples, if the x-coordinate is 3, what's the y-coordinate? So I'd go 3 to the right, and I'd go up and I'd say, hey, this one, there's one answer. The y-coordinate is 7. If I go 3 in this direction, for this graph, hey, what's the y-coordinate when the x-coordinate is 3? Every input only has one corresponding output. I'm just using 3 randomly. So this is 3 to the right. I only get one answer of -1. If I do it for this one, go 3 to the right, and you could have guessed it, this has a y-coordinate of 5. But if I do 3 on this one, I don't get any outputs. That's not a problem. But what if I said, hey, what's the y-coordinate when the x-coordinate is 4? You'd have several different correct answers because this one is not a function. In order for a relationship to be a function, every input can give out at most one output. I'm going to pause here and skip to part 2 on the next page, page 19.